So in my next problem, I have a 10 ampere current source, which is in parallel with a 10 ohm resistor. And I got a 20 ohm resistor here. And I got a voltage source of 50 volts. Alright, and this circuit is grounded here. So I got 50 volts. So according to the question, there is a current Ix. X is difficult to write with my stylus, so I'm just gonna call it IA. Right? So once again, the question is, what is IA? Or basically, if you connected an ammeter, if you put in an ammeter here, what is the current that you would measure? And this is 20 ohms. All right, so let's dive into it. Since you saw in the last problem, this problem is also we're gonna use KCL. All right, so there's these three ends are connected together. So you have, current source, and you have a resistor, and also you have a battery, which is all connected together, and one end is grounded. And then you're doing your circuit analysis there. So according to the question, the current flows in this direction. So just by looking at the direction of the current, you can say, hey, the current always flows from a higher potential to a low potential. So in my question, I'm going to consider this as V. So would V be higher than 50 or lower than 50? It would be higher than 50 because it's flowing from V to 50, even though it's in the other direction. So if you had 50 volts, if the polarity was reversed, you could say, of course, the current is flowing here, and you don't know whether this voltage is below ground or above ground, this potential. But since it's opposing, a voltage of 50 volts is opposing it, and the current is flowing through the 50 volts, we're going to say, okay, yes, we can easily say this potential here is higher than 50 volts. So that is just a way to check your answer. If you're in the middle of solving this problem and you don't know if you're going the right direction or not, so that is just a way to check. All right. So the same type of analysis we did in the last term. So we have, from this node, we have a current which is, let's say, entering here through the 10 ohms. All right. So that is going to be V minus 0 by 10. All right. And then you have IA through the 20 ohm resistor and 50 volts supply. And you got V minus 50. Actually, let me rewrite this in color. Right. So if I consider this, so this would be V minus 0 by 10, and IA would be V minus 50 by 20, because that's the resistance in the circuit. And you have a current which is leaving the node. So the other side is going to be 10 amperes. So check this out. All right. You got a circuit which is grounded. You got two currents entering, and you got one current leaving. So 10 amperes is going to leave, which is going to be on the right hand side, and you got your two currents entering. So let's go ahead and solve this. I'm going to multiply this whole thing by 20. So 20 by 10 is 2. So I would get 2V here. And 20 by 20 is just 1. So I would get V minus 50 is equal to 20 times 100 is 200. So I would get 3V is equal to 250. So my V would be 250 by 3, which is 83.34 volts. So again, if you're at this point and you want to check if your answer is correct, if you have 83 volts, it is higher than 50 volts, so hence your current would flow through the 50 volts battery or the power supply. All right. So now the question is to find IA. So IA is nothing but this branch right here. So we already have the expression for IA, which is V minus 50. This is going to be IA. It's V minus 50 by 20. So if you just put V is 83.34 minus 50 by 20, you get 83.34 minus 50 divided by 20 is 1.667 amperes. Once again, we're making use of our nodal analysis, and we get a current which is flowing 1.6. So why is it so important to know this is when you're selecting this 20 ohm resistor, resistors have different current ratings. So if you select a resistor which has a 1 ampere current rating, if you hooked up that resistor here, right, it would burn because according to your analysis, you have a current of 1.667 amperes flowing through this resistor. So your current rating has got to be at least 2 amperes, at least. That is why it's so important to learn these. All right, let's move on.